Oh, welcome back, and let's take a look at the second part of lesson U1L7. So we're working on Introduction to Exponent Laws. Now this time we have some numerical expressions in exponential form, and we are working on simplifying them. So we're going to start with the first example, 3 over 4 to the power of negative 2. As you can see in here, we have a negative exponent. We cannot evaluate negative exponents. We have to convert them to positive. But first we have to look into the expression inside the brackets to make sure that is in the most simplified form, which it is in this case. So we can go ahead and convert the exponent that is negative into positive, and we do this by flipping the base from 3 over 4 to 4 over 3, and that will change the power from negative to a positive 2. So now we'll apply the distributive property. So the power of 2 is applied to both parts of the base. So that would be equal to 4 squared divided by 3 to the power of 2. Continue simplifying a little bit more. So 4 squared is 16. 3 squared is 9. And the final answer is 16 over 9. Normally, you would check for simplifying if possible, reduce lowest terms possible, but this is good, so we're going to leave it at that. So let's take a look at another example. This time we have negative 6 to the power of 0 divided by 2 to the power negative 3. So since we have this power of 0, we are quickly going to convert this to a single numerical value. So any number to the power of 0 is 1. And in the denominator, we'll have 2 to the power of negative 3. So now that the exponent is negative, and there are no other terms in the expression, so we will convert the exponent from negative to positive by rewriting it as 2 to the power of 3. And that would be equal to positive 8. And that would be the final answer in the most simplified form. Now we're going to take a look at an interesting expression. Now this time we have 2 to the power negative 4 plus 2 to the power negative 6 divided by 2 to the power of negative 3. So we're going to try to do this in two different ways. So we're going to use two different methods. And the first method is what I call the split method. And the second one is what I call the factor method. So we're going to do the split method because it is more basic and simpler. Now remember that 2 to the power negative 4 2 to the power negative 6 are separated by a plus. So if there is a separation between terms with a plus or a minus, by a plus or a minus, these are just terms. So, and 2 to the negative 3 is on its own in the denominator, which makes this a term and a factor. Now, the reason I'm emphasizing this is because I want us to be reminded that these powers do not simplify in here because, or these exponential numbers don't simplify each other because 2 to the negative 6 is, for example, here a term, and so is 2 to the negative 4. So we're going to use the split method. And what is the split method? Well, basically remember that if you have, for example, such numbers such as 1 over 3, and then you add 5 over 3 to it, so then this would be equal to 1 plus 5 over 3. So similarly, if you have 1 plus 5 over 3, you can split this into 1/3 plus 5/3. And I call this a split of this fraction. So in our case, you have 2 to the power negative 4 divided by 2 to the power of negative 3. And then we have plus 2 to the power of negative 6 divided by 2 to the power of negative 3. So we kind of split this addition right here. So we have split this addition into two separate fractions. Notice how when you add them back, you still get the same thing because you keep the same denominator, you just add the numerators. So since we split it, now we are going to simplify, and that's the purpose of splitting them so that we can simplify them with each other. Now they can simplify because 2 to the negative 4 is the only term and a factor of the numerator, and so is 2 to the negative 3 in the denominator. And similarly, we say the same thing, 2 to the negative 6 is simplifiable now by 2 to the negative 3, so we'll do that. And 2 to the negative 4 divided by 2 to the negative 3, we're applying the quotient rule, so that means that would be the power of negative 4, and then we will subtract negative 3. And then 2 to negative 6 will be subtracted, so over 2 to negative 3 will be 2 to negative 6 minus negative 3. Now let's simplify each term. So negative 4 minus negative 3 is negative 4 plus 3, so that's power negative 1. Now negative 6 minus negative 3, so these two minuses will make a plus, and that will make 2 to the power of negative 3. So we're not done yet. We can we can keep simplifying here, 2 to negative 5 and 2 to negative 3. So we can add them, but first we need to convert them into numbers with positive exponents. We cannot operate with negative exponents, so we need the exponents to be positive. So that would make 1 over 2 to the power of 1, so we just reciprocate this, right? That's how we convert negative powers to positive, by flipping the base. In our case, the base is 2 over 1. And 2 to negative 3, guess what? It's going to be 1 divided by 2 to the power 3. Now, simplify. Well, in order to simplify these two, we're going to need to make the denominators the same. There are different ways of doing this. You can make this into an 8 and just add 1/2 with 1/8. I chose to use the exponent laws because that's the theme of the lesson. And in order to make to perform the addition here, we need the denominators to be the same as the lowest common denominator, which is 2 to the power 3, which means that we're going to need to change this denominator here to 2 power 3. So guess what we have to multiply it with? So we need to multiply that by, I'm going to rewrite this one more time. So we need to multiply both numerator and denominator by 2 to the power of 2. And now this will turn into 2 squared over 2 to the power of 3. And 2 squared is a 4, 2 to the power 3 is 8. And this is 1 over 2 to the power 3, which is 1 over 8. And the answer will be 4 plus 1 over 8, or 5 over 8. So this is the splitting method. Now, for the factor method, we're going to use as a name of the strategy is factoring. But before we do that, I want us to go over some simpler exercises so we understand how things are going to work out here. Now, I'm pretty sure this will be probably your more favorite method, and I really, really like the factor method because it can actually help us simplify much more complicated expressions. So I'm going to go over a very popular concept and a term that we use very often, especially in this unit, the greatest common factor. Now, we know that when we have positive exponents, it is very easy and very intuitive and common sense for us to take out the common factor. For example, if we have 2 to the power of 3 plus 2 to the power 7, we'll say that 2 to the power 3 is a greatest common factor. And the way that we choose the greatest common factor is we look at the smallest power. Whichever power is smaller, that's the one that can be common, right? Because if it exceeds the power, it's not common anymore. This is an extra. So if you take 2 to the power of 3 out here, then in the 2 to the power of 3 becomes 1. And what do you think 2 to the power of 7 becomes? So I want you to think about it. So you need to put a 2 to what power will multiply back to 2 to the power 7. So basically we have to subtract 7 minus 3, the power, and that would be 2 to the power of 4. So we're going to have to rewrite this 2 to the power 3, 1 plus 2 to the power of 4. And I bet that this is kind of very familiar to you because we have done this very often in factoring polynomial expressions in this unit. Now, the game changes a little bit when the exponent becomes negative instead. So we're going to take a look at an example where the exponent is negative. So I'm going to take as an example here 2 to the power negative 3 plus 2 to the power of negative 7. So I'm kind of using the same terms, but I'm making them negative. Now I want us to think, when we take out the greatest common factor, right? The greatest common factor, let's say, for example, even if you have, let's say, 6x plus 24, the greatest common factor is going to be a smaller number than 6 and 24 or equal to either one of them. So it's going to be 6, right? So x and then plus 4. This is how you figure out the rest of the terms. So in exponential expressions, when we take out the greatest power, let's say if we have x squared plus x to the power 5, we take x squared out and then we get 1 plus x to the power of 3. So the smaller power will come outside as the greatest common factor. Now, I want us to take a look at both these two numbers and think which number is smaller here. Okay, so is it 2 to the power negative 3 or 2 to the power negative 7? So when the powers are positive, we can very quickly make the decision power is smaller. That means this is a smaller number than this. But when the power is negative, remember that 2 to negative 3 is 1 over 2 power 3 or 1 over 8. Now, 2 to the power 7 is 1 over 2 to the power 7. This is a much bigger number, right, that we're dividing 1 by. What that means is that 2 to the negative 7 is going to be our greatest common factor because that would be our smaller number here. So we're going to rewrite the expression, take the common factor of 2 to the negative 7 out, and then inside brackets you'll have 2 to the power of. Now remember that when you figure out the power left from negative 3, you remove the power that you have factored, just like we did in here. So if you had 2 to the power of 7 and you take 3 powers of it out, then the exponent will become 7 minus 3. So if you take 2 to the negative 7, so you take a power negative 7 out, that means the exponent of 2 to the negative 3 is going to be negative 3 minus whatever power we have factored out. And that takes a little bit of time sometimes to kind of sink in. But I hope that this explanation explains it. And if you have any questions, by all means, come and see me for extra help, and then we'll have a nice little discussion about it. So the 2 to the power negative 7 is a common, is all out, so because it's the greatest common factor. So what that means is that in the inside brackets, we are left with number 1. So remember that this number has to stay here because, is the placeholder for the 2 to the negative 7. So in a more simplified form, now we are going to see that we have 2 to the negative 7 and inside brackets, and this is a little miracle that, we kind of cherish here in this type of expression. So negative 3 minus negative 7 is a power of positive 4, and we like positive exponents because it's easier to simplify them. So with this kind of strategy in mind, we're going to practice, or we're going to try to simplify this expression by using what we called the factoring method. Okay, so you'll see it's going to feel a lot easier when when you repeat this process in a different question. So let's hope so at least. So we have 2 to the negative 4 plus 2 to the negative 7 over 2 to the power negative 3. So what we're going to try to do in here, because we want to reduce this 2 to the negative 3 here, so what we're going to try to do is take out a factor from the numerator, and hopefully that can help us reduce this denominator here. So when you look at these two powers, or exponential numbers, I should say, 2 to the negative 4 and 2 to the negative 6, the smallest number is 2 to the negative 6. Remember, that's 1 over 2 to the power of 6, whereas this is 1 over 2 to the power of 4. So this is the greatest common factor. So that's what we are going to write right here. Now, with this in mind, we're going to start factoring 2 to the negative 6 from the numerator. And then in brackets, we'll be left with, remember, we have a power of negative 4. And we are subtracting the power that we took out. So minus negative 6. And then 2 to the negative 6 will stay, will be just positive 1. And then divided by, so in the denominator, we just have 2 to the negative 3. Now, in the next step, we're going to simplify a little bit this expression. So inside the brackets, we'll have 2 to the power negative 4 minus negative 6. So that means these two will become pluses, right? So negative 4 plus 6 will make a positive 2. So I'm taking the steps slowly in here so that we won't miss anyone. And down here, I brought 2 to the negative 6. And that is because 2 to the power of negative 6, when coming down, becomes positive. And it has a little friend here that can join. And you multiply it by 2 to the negative 3. And look at what happens now. So in the next step, we have 2 squared, negative 4 plus 6 is 2, and then plus 1. And in the denominator, now we're left with 2 to the power of 6 minus 3. That's 2 to the power 3. And the final answer will become 2 squared, which is 4 plus 1, divided by 2 to the power of 3, which is 8. And the answer is 5 divided by 8. So as you can see in here, regardless of the method used, as expected, we got the same answer. So the answer is 5 over 8. So that is very reassuring that these two methods work, right? Now, which one do we prefer? When you look at the number of steps in this particular question, they look kind of equal, right? And it's a simpler expression. But as excuse me, as expressions become more complicated, the factoring will be more advantageous. So, and I'm going to make a note in here so we remember this is a more efficient method because it is more useful in larger exponential expressions. So we're going to try this one here. And don't be surprised if you see a question like this on the test as well. But we are learning it, right? So it's not difficult. I want you to think, first of all, what you have. You have 2 terms in the numerator and the difference of 2 terms in the denominator. And what that means is that these terms do not chop. And I can't count the number of times when people simplify this, when I see students simplify this, but that is incorrect. And if you have an idea of simplifying that doesn't sound very reassuring to you, try to put the numbers in the calculator or try to use numerical examples to see if your idea works, okay? So you can try it in, by following all the rules the long way and by the simplification method that you are suggesting. And if you see that the answers are exactly the same, then probably you'll be right. Long story short, we're going to start simplifying this now. As you can see, you have powers of negative 6 and negative 7. The smaller number is negative 7. So 5 to the power of negative 7 will come out as the greatest common factor. And 5 to negative 6 will become 5 to the power of negative 6 minus negative 7. Now, plus 5 to negative 7 is all out, so plus 1. And then in the denominator, we'll have again negative 7 is the smaller number, the smaller power. So 5 to negative 7 will come out as a common factor, greatest common factor. And inside the brackets, we'll have 5 to the power of negative 6 minus negative 7, and then minus 1. So minus this one in here, right? Because that is all out. So look at how beautifully these two simplify. And that's exactly what we're going to do. Can't wait. And let's take a look at what we are left with. So here we have negative 6 plus 7. That's going to be equal to 5 to the power of negative 6 plus 7 plus 1. And I'm taking all the steps here. By all means, go for 5 power of 1 directly here. And down in the denominator, we have 5 to the power negative 6 plus 7 minus 1. Simplify some more. We have 5 to the power of 1 plus 1 over 5 to the power of 1 minus 1. And that will give us 6 in the 5 plus 1, or 6 in the numerator. Boy, I really took all the steps here. And then 5 minus 1. So 5 plus 1 is 6, 5 minus 1 is 4. And then you check and see if you can reduce the answer to lowest terms possible. And voila, this would be your final answer. Now, if you try to do this, and I've seen people do trying to make it happen. So if you try to convert the exponents from positive to negative, this is going to be a long and winding road, and it's not going to be that much fun because it is very, very easy to mix up the terms, and it is more work. And when we have fractions inside fractions and funny looking exponents, it doesn't become a lot of fun because it's easy to get lost, but it's not impossible. So if you want to try it for fun, go for it. It's fun to play with numbers. I'm using the word fun very often, but it is fun to play with numbers. So try it if you wish, but don't forget the factoring method. Try to practice this question on your own. So create a question if you wish, and then try to practice it on your own and have fun with it. So I am going to close this off here, and I just want to thank you for learning with me again, and bye for now.